Hello, welcome back to episode number 3 on the series on mechanics, the statics aspect. In just ended episode, we deal with frictional forces on both plane surfaces and on horizontal surfaces. And we did promise that we'll be picking the equilibrium on those surfaces, either on the plane surface or on what inclined surfaces. For a plane surfaces, there are some cases we did mention that it could be a force applied to the object, and the force applied is also horizontal to the surface. Then we also have a case whereby the force which is applied to the object is not horizontal but rather an inclined angle to the horizontal. This is the horizontal line which is parallel to this. So the force applied is in this form. So in the resolution of these forces, we can tell from here, this is the normal reaction, this is the weight, this is the upward, and this is what? Downward. And in here, we can see this F here is showing frictional force, the resistance of or resistance force against the push. So in this case, if I am picking vertical forces here, which is this, that will mean that the normal reaction will be equals to the weight of the object. That is the vertical reaction for a third law of motion. For every reaction, there is equal and opposite what reaction taking place. So this will show vertical forces acting on the object. The earth is acting on it as a normal reaction, and the body itself is acting. Then let's look at the horizontal forces. Horizontal forces here. This is also going to be, this force is going to the east, and the frictional force is preventing it by going to the west. So these are equal and opposite reactions. So here we can also say that the frictional force is equals to what? The push or the force applied. Don't forget, we already know what the frictional force is. We know the frictional force is also equals to the coefficient of friction times what? Normal reaction. And this friction becomes zero if the surface is what? Smooth. We talk about that in the other episode. And in this case, we can see the force applied is not directly horizontal to or parallel to the surface on which the object is placed. So that means that there is other forces introduced, forces as in movement. So you can see this force from here is acting downward and acting what? Parallel. If I pick this side, this is the opposite side, this is the adjacent side, and this is going to be the force applied. So if I look here x, okay, let's make it y to look nice. If I'm looking for y, I'm going to have opposite hypotenuse. That is the sine of that angle equals to the opposite over what? The hypotenuse. Cross multiply, y will be equals to p times what? The sine theta. So this here is going to be p sine theta. Are we good? Then if I am picking this side, which is the x, it is also going to make use of the hypotenuse and the adjacent. And hypotenuse and adjacent make use of what we call the cos, or the cosine. So the cos of the angle equals to the adjacent side, which is x, over the hypotenuse p. Cross multiply, x become p cos what? Theta. So here will also be p cos theta. Alright, so what are we going to do? If you want to find the vertical forces, I'm sure we're not having enough space, but let's see. If I want to find the vertical forces, in this case, vertical forces, I can see that this is moving upward. This force is moving upward. This force is vertical, is moving downward. This force is moving downward. So upward force equals to, or the sum of the upward force equals to the sum of what? The downward force. So here I can say that the upward force is what? Normal reaction is equals to the force coming down, which is P sine theta, plus the force coming down here, which is what? The weight. Don't forget the weight is the same as what? The mass times the gravity. I don't know if that is clear. Then let's look at the horizontal. Should I use, okay, let's see. So for the horizontal forces, this is moving towards the east, and this is coming to the west. So they are all horizontal, or let's say horizontal or parallel. Okay, let's take it that way. So this is moving to the west, this is moving to the east. So we can say that the force, which is the frictional force, equals to P cos what? Theta. I'm sure you are following the resolution of the forces. We have vertical forces, and the vertical forces, some move up, some move down. So the upward force will be equals to what? The downward force. And in this case, it is only the normal reaction that is moving upward. Then the weight of the body is acting downward, whilst the force applied is having an inclined nature. So that force is also moving downward. So the sum of the downward forces, which is P sine theta plus the W, should be equals to the upward force, which is what? The normal reaction. This is what we can get for the second case. When the body is on a horizontal surfaces, there are cases whereby here the push, it is not only push. There will be a time that there is no push. In this case, we can see this is the frictional force. If you apply this, if a push is here, it will be moving in the same direction as a push. If a pull is here, this push and this is what? A pull. When you pull it, it will be in the same direction. Then what we are seeing here as a force applied can also be a force which is being applied by pulling, by a string. So when a string is attached, it's not going to be horizontal but forming what? An angle incline here. So this will now be on the other side, which is moving in the direction, and vertical, all in the same sense. Then we come to equilibrium on an inclined plane, where there is an angle. The body is raised above the horizontal, creating an angle. So this is when there is a body placed on inclined surfaces. I think let's introduce this to show the inclined nature of the surface. The inclined nature of the surface. So these are the surface. So we can distinguish this one from the horizontal line, or let's say the ground that we have. Now, in this case, where we have a body placed on a surface where there is a force applied, or there is no force applied, there is no force, but there is the surface is rough. Therefore, the force that is moving downward is equal to the force that is moving upward. So the frictional, when the body is sliding down, the F there is going to pull it up, or let us maintain it, if I could say. That is the frictional force. So if the force that it will cause the body to come down is equal to the frictional force exerted by the body, then we have equilibrium. The body will be at rest, no movement. So this is just like we place a book on an inclined surface, or a table that is inclined. When the book is staying there, it means the frictional force acting on the book in the opposite direction is equal to the force that could have moved the body to slide down. So that is what we are seeing in this case. So we can also use vertical and horizontal, or vertical and parallel. Okay, let's distinguish it. Let's use perpendicular. The vertical ones are going to be perpendicular to the surface. Then the horizontal one here, we are going to use it to be parallel. So I think I need space. Let's clear here so that we direct the explanation to the left side. So for the first one, under the first, which is the case 1, if we pick the case 1, picking, let's use parallel forces. If I say parallel forces or forces that are on parallel to the surface on which the body is placed, I can see that this is moving to opposite direction to this. So that will give you your frictional force will be equals to mg sine theta. The sine theta, mg sine theta and cos theta has been derived in the first episode. How that area becomes sine theta and cos theta, it has been derived. You can check that in the first episode. Then let's check the vertical. So let's say perpendicular or to the perpendicular to the surface, right? Then if perpendicular to the surface, we know that R is perpendicular to the surface, then this is also perpendicular to the surface. So I can say that the normal reaction is equals to mg cos what? Theta. Don't forget that the coefficient of what do you call it? Friction. It has been given to us from the previous episode, as in your force is equals to the mu times normal reaction, making your mu equals to the force over what? The normal reaction. That is for the case 1. I think this has been derived in the first episode. I think first and second episode or so. Then here there is a force applied. The force that is applied to the object, and that force is equal to the friction. Therefore, the body is still in there. Now, when the body is at equilibrium, it means that there is no acceleration, no movement. The body is not sliding down, it's also not moving against the friction. So if in that case, this is our friction. If you check, we are having this arrow in there, and as we are pushing this in, there is a friction. That friction is, let's see, when the body is not moving, right? When the body is not moving, the force here, which is the F, is the one causing the body, the frictional force, from sliding down. But when you push it, the frictional force is not moving in that direction again, because it is always moving in the opposite direction to the force applied. So if I apply P against the object, it means the frictional force now will come down. So it moves and come down, preventing it from moving. So you can see there is a movement, this friction, and this limiting friction, this force, and this limiting force are moving in the same direction. So these are frictions that are moving to the right or to the east. Then this is the forces, as if friction, forces, right? Forces. And these are forces also moving in the opposite direction. So if I am to pick the parallel forces, resolution of forces on the parallel direction, I'll be considering the force that is going to the east, as in P plus F should be equals to the force that is coming down. That is what mg sine theta. So we are adding this because moving in this direction, there are two forces that are moving to the east. On the normal scale, when the body is at equilibrium, there are two forces here. This force and the one pushing it. And the one moving down is the one preventing it from sliding down. So we have that. Then if we take the perpendicular one, or resolution in the perpendicular direction, let me underline them. Perpendicular. Do we see any perpendicular? To the surface, not to the normal ground, but to the surface on which the body is placed. I can see upward perpendicular to the surface, downward perpendicular. So that will give us only normal reaction equals what? Mg cos what? Theta. That is for the second case. So let's go to the third case. For the second case also, we know that this is equal to this, and this will also be equal to this. if we are talking about the force on the body when there is no push, this F will be equal to this. And if there's a push, then this and this equals to this one. All right. Let's see the case 3. And in the case 3, we can see that this is going to be in right angle. If you draw it well, it will be in right angle. So this is also going to be opposite side. This will be the adjacent side. So if this is the opposite, this becomes the hypotenuse, which is the P. And if I use that, it means that opposite side, which is Y, will I use cos? This is opposite. So sine of the angle equals to the opposite side over P. That makes Y equals to P sine theta, meaning the one that is moving vertical is going to be P sine theta. The one that is moving vertical, it will be moving down. So I have P sine what? Theta. Then, since I am pushing it at an angle, there is a force coming down from where the P is, and it is also going to be inclined. This and this, we will call a resultant force. So this plus this will be equal to this. So as this comes down, it must also move in direction to push the force. So that is also moving towards the object. That force that is moving towards the object is going to be the adjacent side, and that will be taking the P cos what? Theta. If this is taking sine theta, remember the trig function, sine, cos, and trig tangent, we can be able to do that easily. What do we do from here? We are going to resolve the forces in parallel. So let's take the parallel direction, or parallel forces, resolution of forces that are parallel to the surface. Looking at surface, I can see this force is moving in the direction of the F, and that is the only thing that is parallel. Then there is a force moving down, that is the opposite direction. So these two forces, which is going to be F, the top F, plus the one coming towards it, which is P cos theta, should be equals to mg sine theta. I guess we are looking at the opposite direction. This force is moving to the west, if I can say. No, it's moving to the east, and the F is also moving to the east. Then the mg sine theta is moving to the west. So they are the opposite side. So opposite and equal reaction. So let's come to perpendicular to the surface. Perpendicular to the surface. What forces are perpendicular? I can see this is perpendicular to the surface. The normal reaction perpendicular to the surface. The opposite side of the normal reaction is also perpendicular. And this is moving downward. This is moving downward. So the downward forces will be equal to the upward forces. So normal reactions will be equals to P sine theta plus mg cos what? Theta. Alright. These are the resolution of forces that are done on inclined planes. Now, if you check this is just when the body is on the surface, not moving, not sliding down. This is when the body is on the surface, but there's a force applied to it. And that force is equal to the friction. Therefore, there is no movement, no acceleration. This is also same, but in this case, the force applied is in an inclined angle to the horizontal surface. So that will also give you. I'm sure we said this angle and this are the same because of this line is parallel to this. So we can have our alternate angle in here. I'm sure the concept is clear. All these things will become meaningful if we were to pick a question and apply the concept we have discussed. It could be any of the concepts present in any question. 2 or 3 can be in the question, or just one concept in a question. We are 20 minutes and above, so the episode that will follow will be where we pick examples to test these hypotheses that we have discussed in this episode. Don't forget to share the video, like the video, leave a comment, and subscribe.